Hello, Professor. This is my assignment for topic 8. I'll now share my screen to explain my codes. I share here. And what I have here is the selected database that has various health-related features related to diabetes. The approach used in EDA is to find hidden patterns or relationships, which includes summary statistics here. After I loaded the data set, I looked at this summary statistics here, and I checked for missing values. Also, I did data cleaning for duplicates. Then I did the summary statistics again. Now, the visualization uses histogram to show the distribution of diabetes, as well as pair plots. And I also use scatter plots and a heat map. Here, this pair plot that I have helps to visualize the relationships between variables, including potential correlation or pattern. And the heat map here represents the strength and direction of linear relationships between pairs of the numerical variables in the cleaned data set. Now, some potential research questions are, does age play a significant role in determining general health issues? And the hypothesis is older individuals are more likely to report higher general health status compared to younger individuals. Another question could be, is there a relationship between high blood pressure and self-reported general health? And the hypothesis would be there individuals with high blood pressure are more likely to report lower general health compared to those without high blood pressure. And another research, I have a lot of research questions here. Another one would be, how does physical activity influence general health? And the hypothesis for that one is higher levels of physical activity are associated with better general health. What I have here is the correlation matrix or the heat map. I also did the Pearson correlation matrix and the Spearman's correlation matrix. And these are my values here. And the insights from the Pearson correlation matrix shows that there are moderate positive correlation for diabetes and high blood pressure, also for high blood pressure and heart disease or attack, as well as for general health and high blood pressure, all showed moderate positive correlation. Also, the Pearson correlation matrix also showed negative correlation for physical activity and general health, as well as education and income, which were all moderate negative correlation. The Pearson correlation matrix showed moderate positive correlation for diabetes and high blood pressure, as well as for high blood pressure and heart disease or heart attack. Also, Spearman correlation matrix showed a moderate negative correlation for physical activity and general health, as well as for education and income. There was also a moderate negative correlation. Now, I fitted the regression line for independent variable and dependent variable. The independent variable is general health, and the dependent variables are high blood pressure, BMI, physical activities, income, and age. And the fitted line also is referred to as the regression line, represents the best fit to the data points in the multiple regression model. These are the results that I have here. And an example is looking at the fitted line here for high blood pressure. These are all the fitted lines. High blood pressure versus general health. As the blood pressure increases, it shows there's a tendency for the general health to be slightly higher. And the regression line has a positive slope, indicating a positive relationship between high blood pressure and general health. That's one example there. And my assumptions here that I show, the appropriate techniques to validate the assumption are linearity. I did linearity where this scatter plot, this is the scatter plot that shows that each independent variable here, that's the scatter plot, that shows each independent variable, which suggests a reasonable linear relationship between the independent variables of high blood pressure, BMI, physical activity, income, and age for the dependent variables of general health. And the linear relationships follow a general linear trend supporting the assumption of linearity. For normality of residuals, this is the histogram of residuals, which shows roughly a symmetrical distribution. It resembles a bell curve, and this suggests that the residuals are approximately normally distributed. I also have here a QQ plot of residuals, and there are comparisons of the distribution of residuals against a theoretical normal distribution. The residuals roughly follow the diagonal line, indicating that they're not significantly deviating from normality. What I have here is the plot for that shows is a scatter plot for homoscedasticity of residuals versus predicted values, which show that there's no noticeable pattern and the spread of residuals appears relatively constant across different levels of predicted values. The residuals are evenly distributed above and below the zero line, indicating homoscedasticity. And generally, for all these plots, which the assumption of linearity, normality of residuals, and homoscedasticity appear to be reasonably met. Now for the summary of what I did, is the report explores the relationship between various health-related variables and self-reported general health based on a clean data set. The analysis involves data visualization, summary statistics, statistical correlation analysis, and regression modeling. The summary statistics provide insights into the central tendency and variability of the clean dataset. A correlation matrix visualizes the relationship between variables, and the EDA uses univariate analysis to explore the distribution of individual variables, and bivariate analysis to explore relationships between variables. The data cleaning addresses any issues identified during EDA, such as missing values or outliers. The regression modeling was done by building a regression model to understand the impact of selected variables on general health. And the key findings from the analysis is, for example, a positive relationship between age and general health, while high blood pressure and income show significant association with general health. The regression model explains approximately 21.1% of the variance in general health. And that's my presentation. And now I will stop sharing my screen, and thank you.